All right, perfect problem 6 for Math 60. Looks like we're given 3 tasks here. The first one is to graph the solution set of this equation. Okay, so 2y minus 4x equals 8. We'll learn lots of ways to graph this guy, but the only way we know now is by finding 2 points that are on this line and then plotting those 2 points and then connecting those 2 points with a straight line because we recognize that this right here is linear. The way we were taught to do it is to find the x-intercept and the y-intercept. Let's see, the x-intercept is kind of saying where does it cross this x-axis right here. And what I want you to notice is that it's going to cross this x-axis when the point, with the height, the y value, the y-coordinate is exactly 0. So the x-intercept comes when y equals 0. And if y equals 0 up here, our problem reduces to just negative 4x equals 8. Right, 2 times 0 is just 0. So negative 4x equals 8. If you divide both sides by negative 4, you get x equals negative 8/4, which is just negative 2. So what that tells us is that our x-intercept is over here at negative 2. Alright, we can do something similar finding the y-intercept. See, the y-intercept is asking when does it cross this y-axis up here. The y-axis will be crossed when the x-coordinate equals 0. So to figure out this guy, we let our x equal 0. And if x equals 0 up here, the problem reduces to just 2y equals 8. Divide both sides by 2. We get y is 8/2, which is just 4. So what that tells us is 1, 2, 3, 4. Our y-intercept is right here. So to graph the solution set, all I have to do is connect these 2 dots with a straight line, which is a little bit hard to do on a computer, but more or less like that. Throw arrows on it if you want. And what that's saying is that any point on this line is a solution to this equation. So that takes care of number 1. Maybe I'll switch color here. Number 2, graph a second line whose x-intercept is 2 less than the first equation's x-intercept. Okay, so the first equation's x-intercept is right here at negative 2. So we want 2 less than that. So for our next line, we want the x-intercept to be over here at negative 4. And whose y-intercept is 1 less than the first equation's y-intercept. Okay, the first equation's y-intercept was up here at 4, so the new one is down here at 3. 1 less than 4 is 3. And now we have 2 points, and I can attempt to connect those with a more or less straight line. Not too bad. And we've now completed task 2. Task 3, which I thought was the hardest of the 3, I thought it was pretty tricky, is it saying, okay, the equation of the second line, the red line right here, maybe I even draw an arrow to it, is ay minus bx equals 12. And what I want you to do is figure out what a is and what b is. These are just numbers. What numbers are they? And kind of the way I was hoping you'd go about this is you'd be like, all right, we're going to kind of work backwards but do the same thing we did here. The x-intercept, that happens when y equals 0. And if y equals 0, our problem is just negative bx equals 12. Right? This is 0, this goes away, so we got negative bx equals 12. And we know that when we solve this equation, we get this point over here, 4, right? With this, our x-intercept happens at, negative 4. So we know that the solution to this equation is at negative 4. That is, x will be equal to negative 4 when we solve this thing. Maybe one way to write it is, we know that x is equal to negative 12 over b, but we also know that x is equal to negative 4. So kind of the question is, what does b have to be to make negative 4 equal to negative 12 over b? B has to be equal to 3. So that's pretty difficult. Hopefully I helped you guys out in class with this a little bit or something, but that's the idea. We figured out that this b right here has to be 3. We can do something similar to figure out what a is by using the y-intercept. See, the y-intercept happens when x equals 0. So if x equals 0, our problem reduces to ay equals 12. And we know that our y-intercept ended up being at 3 up here. So we could say y equals 12 over a. That answer has to be 3. So what does a have to be so that 3 divided by 3 equals 12 over a? Well, a has to be equal to 4. So for our third one, if the equation of the second line is that, find a and b. Got a here, got b here. So that's the end of this perfect problem.